Okay, let's see section C, nonlinear first ODE, the type 2 homogeneous differentiation equations. Now, before we see the solution for these questions, let me remind you what we have learned in the class about the type 2 homogeneous differentiation equation for the first ODE. Okay, so for the first ODE, it is a homogeneous differentiation equation if we can express the differentiation equation in this form, which is f a function of y divided by x, meaning that we express the right hand side as a ratio of y divided by x, and then we can use v equal to y divided by x and substitute over here. Then we have a function of f of v. That means we change two variable y over x to the single variable v. If we are able to express these kinds of the differentiation equation, this is called as a type 2 homogeneous differentiation equations. Now, we have a general formula to find the solutions of these type 2 homogeneous differentiation equations. So the general formula for this is integrations of 1 over f of v minus v dv, and this must be equal to the natural log of x plus c. So this is the general formula. Okay, so for these questions we are going to directly apply the general formula to find the general solutions. Okay, so let's see the questions 1. We have y prime equal to 1 divided by cosine of y divided by x plus y over x. Okay, now we can express y prime as dy dx, and this is equal to 1 over cosine y divided by x plus y divided by x. Okay, now we express the right hand side as a function of v, so we let v to represent the ratio of y divided by x, and then we substitute into our equations. So it's 1 over cosine v, so 1 over x we replace with v. Okay, now the right hand side can be expressed as a function of v, then we can directly apply this formula. Okay, now we are going to directly apply this formula, so we do the integrations of 1 divided by f of v minus v dv, right? So f of v, this is the f of v, so this one is the f of v, so we directly apply over here. So we have 1 divided by 1 over cosine v minus plus v minus v dv, right? And then we can cancel out v minus v equal to 0. So over here we have 1 divided by 1 over cosine v dv. So this is equal to cosine v dv. So we are integrating over cosine v. This gives us sine of v. Okay, sine of v. So this is our result of integration on the left hand side. Now, so the general solutions of this differentiation equation is sine of v, and this is equal to the right hand side over here. Okay, equal to this. So we have a natural log of x plus c. So this is our general solutions.